Hello, in this video I'm going to be showing you one of the more popular problems. I don't want to say it's like a very popular problem, everyone knows it, because then if you don't know it you feel like you're trash or whatever. Okay, this is the 2004 MC 10A number 22. Square, sound like square. Square ABCD has side length 2. A semicircle with diameter AB is constructed inside the square, and is tangent to the tangent to the semicircle C intersects side AD at E. What is length CE? Okay, so this is a problem that's much easier understood when it's graphed. So we are going to have A, B, D, and C. We're also going to have a semicircle that is tangent to that line. Oh, that was a bad semicircle. Oof. Oof. Let's draw that better. That's good enough for our sake. And we call this E. Now this length right over here is 2. So it says, what's the length of CE? Well, this looks like it's pretty tough. It's not like CE is the AC. I would just use the Pythagorean theorem. This problem looks a little more tough. Now, if you remember your geometry, remember that any two tangent lines of circles, since they start at the same point, they're going to be equal to each other. So C, and we will call this point F, is going to be equal to CB. Also, just for later on, this is going to be called G, just giving you a heads up so that, whatever, for the future you know. So this length is also 2, so all we need to find is EF. I'm going to call that X. Now using the same thing that we used to say that CF is equal to CB, we're going to say that EF is equal to EA, so this is going to be X. Now remember how this whole thing, I actually saw somebody draw it like this, the squiggly thingy like this, and it's so cool. I don't know why I was never taught that at school. This is equal to 2, so this DE is going to be 2 minus X, and this is just going to be 2. So from here, one of the things you can do is just use the Pythagorean theorem. I could say 2 plus X quantity squared is equal to 4, which is 2 squared, plus 2 minus X. Now, squared, sorry. I'm going to just quickly go over what all of these are equal to. I draw Punnett squares to do this stuff. And it's like a cool exercise. You're trying to fill it in. So I have x squared plus 4x plus 4 is equal to 4 plus, and then 2 minus x, 2 minus x, 4 minus 2x minus 2x, x squared is equal to 4, so it's 4 plus 4, so I'm just going to say 8 plus x squared minus 4x. Now these two x squareds cancel out, so we have 4x plus 4 is equal to minus 4x plus 8. So now what I'm going to do is I'm going to move this over here and this over here. Another way to, I'm out of the shot. Another way to think about it is subtracting on both sides. So we are going to be left with 8x is equal to, I'm trying to stay in the shot right now. 8x is equal to 4, that means that x is 1/2. Now if x is a half, that means that CE is going to equal 5 halves or 2 1/2. So that's one way of solving it. There's also another way to solve it that I like to show you. Just to note, there's like a gazillion ways to solve this. I'm just not going to go over all of them because it'll take a gazillion hours. Really mathematical. Alright, so like I said, later on we're going to be calling this G. So I draw an imaginary point right here. First of all, it's important to note that this is 1 and this is 1. Okay, and let me put this down for a second. I'm going to draw this quadrilateral BCFG, and I'm going to say that that is similar to AGFE, okay? So if you just take this, and you turn it like that, then you'll get the same image, okay? So that means that BC over FG is going to be equal, sorry, BC, not DC. So BC corresponds to AG. Now AG is also the same thing as GB, so you can write either one of them. Just gonna write GB, doesn't really make a difference, and then over EF. So FG, when it's turned, it's EF. Okay, so now we can fill in these numbers. BC, so we have 2 over FG, which is, since this radius is 1, this radius is 1, is equal to GB. GB is equal to 1 over EF, and EF we called X. Now, the reason I wrote these exact equalities is so that we would have one that has EF, and the other fraction that we would have is a 2 or some known length, preferably without X in it. You could do it with X in it. It's still simple algebra, but it makes your life a bit harder. So I did one that was just plain 2. So now there's a cool thing where you can just like swap the order of both of those, so you get X is equal to 1 over 2. And then again, you just do 1 over 2 plus 2. You could write it as 2.5, or you could write it as 5 over 2. Either way, that is your answer. Thank you for watching, and goodbye.